Good day to all. Today we are going to see the another type of speed control method, which one is tapped field method. See, you can see here the supply voltage V is here. Here it is the supply voltage, and we have a motor. Here it's a A1 and A2. From that supply voltage, we have a coil like this: 1, 2, 3, 4, 5. It will like a tap, right? The flux change is achieved by the changing the number of turns of the field winding. See here the field winding have a number of turns like 1, 2, 3, 4, 5. So when we are give the supply, according to the supply, the power will flow from here to there. If we are keeping these turns over here, then that will have some current will flow. If you are keeping this here in the 3, then we have some current will flow, as well as if you are keeping here in 4 means some current will flow over there. Then if you are giving in 5 means there also different type of currents will flow over here, the current IA. From this differentiation, we will easily control the speed of this motor. Here we will tap according to this tap of field method. Then we can vary this speed of the motor. We can vary the flux with the help of this topping the number of turns of the winding. This is the tapping field method. Here you can see series and parallel connection of field. In this method, field coil is divided into various parts. These parts can be connected in series or parallel as per the requirement. See, if you are seeing figure 4.1 to A and B, so the two parts of field coil is connected in series as well as parallel. The main concept over here is the field coil is divided into two parts. Here the field coil is divided into two parts. From this we will have a control over here in this motor. Here this divided coil, because if you are giving the supply, then we will have some voltage drop over here as well as some voltage drop over here. From this we will rotate this motor according to the motor's rotation, and we will have a voltage drop over here. From that we will control this motor. Like here it is in series, and this field here it is in that parallel. Here if you are giving the supply, then the current get deviated from here, some current will flow, and here some current will flow. At the time of current flow here we will have some running, and as well as in below we will have some running. For these operations we will get the control of that particular motor. Then that this one is a rheostic controller. See here the supply voltage is directly connected with that RX. The variable resistance RX is inserted in the series with that motor. You see here the motor is series with that RX. Then the voltage drop across this resistance IA RX is occurs. See here the voltage drop occurs for IA. Here IA is there and RX is there. This reduced voltage occurs the armature also. So if you are giving the supply, the IL will come over here and it will pass us through the RX. Then there is some voltage drop according to the resistance which we will given. From that resistance, the voltage across in that armature also takes place. With that voltage armature, we will have the running of that particular motor. If we are seeing that graph for speed and current, see this graph have a speed decreasing with increasing the current. This is with Rx, with this variable resistance, and without this variable resistance. If it is without variable resistance, speed also have a more value than that with the variable resistance. This is the rheostat control. Then the applied voltage control. See, if you are seeing that applying voltage control for permanent magnet is connected with the generator. This generator will have the connection of generator field, which has the winding as well as the variable resistance Rs. Then this will connected with the series winding, then that will go into that motor. Here the voltage is applied from generator is controlled by a field divider resistance connected across the series fielding winding the generator. So with this adjustment we will have the control over here in that motor. Then the Warner-Leod system speed control method. If you are seeing here, the supply is given to that motor 2, and this motor will connected with the generator, and this generator will connected with that motor 1. So here we'll have a connection supply over here. If you are giving a supply, then this motor will rotate and give the power to the generator. Here power generator is running. With this changing the switches, with the help of this changing the switches, we can control this generator. With the help of this generator, we can control the speed of this motor. This is the main concept of here in that Warner-Leod system of speed control. And this system is commonly employed for elevators, roads, and main drive in steel mills. Then the modified Watt-Leonard system is called Watt-Leonard-Ellinger system, in which the flywheels used in addition of motor generator set. See here we can use that motor as well as generator. In that new method we can call this Watt-Leonard-Ellinger. In that method we will use, instead of this motor and the generator, we will use the flywheel over there. But here we are controlling this motor with the help of adjustment of this generator switches, because the power supply is given from the switches to the generator. From this varying, we will have the varying in this generator. This will varies the speed control of this motor. From that we will control the speed of this motor. This is the Warner-Leod system speed control method. Now we will have the advantage and disadvantage over this motor. First one is, it is smooth variation of speed over wide range. It has a smooth variation of speed. Then rapid and instant speed is reverse. The thing is, speed is reverse is the instantly it will take place. That is the main advantages over here, as well as the rapid. And then the speed control above and below rated are also possible. As we know already, what is that rated speed? Most commonly the rated speed is 1500 rpm. So this is the rated speed of the motor. We can control the speed for above rated speed also, as well as the below rated speed also. It is possible over here. Then the speed of the regulation is very good here. But the thing is, the main disadvantages over here is efficiency is low. as well as that initial cost of the setup is also very high. These two are the disadvantage of this system. Thank you.